In this video, I will be showing you how to make your standard curve using the information that you collected in class. So this is the example of what type of data you would have received in the Blackboard file from the plate reader for your BSA protein dilutions as well as your actual unknown dilutions. You are going to go in there and look at the 595 values. These are values for absorbance at 595 wavelength, which is the value at which we were testing, in which we would have looked at the Bradford assay changed color of blue. So we are going to go to our row. In my case, the proteins dilutions were put in row C, so I'm going to copy the 595 values for absorbance and copy them over to the second sheet where I am making my graph and doing my calculations. So you can in Excel tell it to put the values and switch them from rows to columns or columns to rows. So I'm going to go ahead and tell it to switch it from the horizontal format to the vertical format. So now I have my dilutions already written in. These were the dilutions of our BSA. So this was the concentration in each one of our dilutions. 0 is our blank, which was just millicube water by itself. Now if you look here, the millicube water by itself also has a value associated with it. So that's the background noise that you have from the assay itself. And before we can actually look at the making the standard curve, we need to remove that background noise. In order to do that blank correction, I'm going to first copy this column with the BSA dilution concentrations, and I am going to paste it in this second column over here. So this is BSA protein concentration, so I just want to change that. And then I will add the blank corrected A595 values here. So these are going to be blank corrected. And that's the final value that we actually want. So our blank is 0.387. That's the value we are going to remove from all the other numbers. To do that, you can put in a formula in Excel file and you can say equals, I want it to take this number and I want it to subtract 0.387, which is the value for no protein in there, 0 or blank. And now you see that we get a 0 for our final A595 value for the blank. So it's zeroed it out. And then you can move that same formula down to include all the other protein concentrations by clicking, right click on this little plus sign and drag it down. And here you go, you have all your blank corrected A595s available now, ready for us to plot them. To make the graph itself, you can select these two columns at this time, the rows and columns that are going to be included within the graph. And I'm going to now go to insert and then look at a scatter plot. For this particular graph, we just want a scatter plot, something like this, and that's what I will choose. You're going to go ahead and choose this. I'm going to go ahead and move it down so I can play with it and finish formatting it completely. Now, the first thing you want to do is remove all these grid lines because we don't want them in the final graph. Also remove the title because in a biological or scientific writing you want the title and caption to be at the bottom of the figure and not at the top. You are then going to go ahead and format the axes. You can say format axes and make sure that it is formatted properly. So I want to make sure that it is formatted as numbers. I will tell it to be number and tell it to go to 2 decimal places. That's fine. I will do the same over here and make sure that it is formatted as a number and has 2 decimal places. However, your X and Y axes don't have to match in the number of significant figures. Just all the numbers within each axis should look the same. Now, next thing we want to do is add titles. So I will do that over here. I'm going to make it a little bit smaller so it's easier to see the title itself. And now we are going to add the titles. So in the x-axis we have the BSA protein concentration in mgs per mil, so milligrams per mil, and in the y-axis I have the absorbance at 595 nanometer. Next, you want to go ahead and you want to change the color to black or gray, whatever you would like. Now this graph is almost formatted. The last thing you want to do here before you look at anything else is to make sure there are no borders. So again, you can do that by saying format chart area, make sure the border says no lines. And now it is formatted except for the equation that we are going to put there, the trend line. Before that, I'm going to go ahead and duplicate this graph. So I'm going to say Control D, and now I have an exact copy of this graph. These are your 2 side-by-side scatter plots that you're going to then export into your document once you're done putting in the actual equations in there. In the first one, you are going to go ahead and add a linear trend line. So you will say add trend line, linear, more options, and then you will go ahead and add the equation and R-square value on the graph itself. Also, you can change the color of your outline itself to gray or black or whatever you want, just no actual color. In the second graph, you are going to do the same thing, but this time you are going to add a polynomial trend line. So you will say more options, you will go into the equations, you will say polynomial, and again you will display the equation and the R-square values of this particular line on here. And these are going to be the 2 equations that then you will have to work with in order to calculate your protein concentrations. Again, you want to go ahead and change the color to a gray or some other neutral, black or gray. So here you have the final formatted figure 1 graphs that you can now export out by going by using the copy function and then pasting them into your Word document itself. Once they are there, you will add the title and caption underneath to talk about what it is that's presented and what it means. Also label one A and the other one B to make sure it's clear to the reader what it is that you are referring to in each case.